Welcome to JTT Education Channel Sri Lanka. Today we are going to learn the first part of programming in Python for A-level Information and Communication Technology. Like the video, subscribe and get notified about the next lesson. Let's learn about the problem-solving stages. The problem-solving stages include problem analysis, build an algorithm for the problem, coding and troubleshooting done by the programmer, and implementing a computer program. Let's learn what is an algorithm. Algorithm is a step-by-step process used to solve a problem. Also, an algorithm can be graphical or textual. The graphical representation of an algorithm is called as flowchart, and textual representation of an algorithm is called as pseudocode. It's time for us to learn about the graphical representation of an algorithm, and that is flowcharts. Under this, we are going to learn the Ansi standard flowchart symbols, and in order to draw the flowcharts hereafter, it's a must for you to remember all these symbols we are going to learn here. The first symbol is the terminal, and this terminal is used to represent start and stop of a program. The second symbol is the process symbol. Rectangles are used to represent the process. The third symbol is the input and output symbol. Parallelograms are used to input data and output information. The fourth symbol is the decision symbol. Diamond shapes are used to check any condition or take decisions for which there are two answers. It is yes, that means true, or no, that means false. Fifth symbol is the flow lines or arrow. This is used to connect symbols and also used in flowcharts to indicate the direction of flow. The last symbol is the connector, and it is used to connect joins or flow lines. After finishing off learning about the Ansi standard flowchart symbols, it's time for us to learn the Ansi standard flowcharts. Under this, we have to learn about the processing box. When more than one arithmetic and data movement instructions are to be executed consecutively, it is normally placed in the same processing box and assumed to be executed in the order of the appearance. The normal flow of the flowchart is from top to bottom and left to right, and the flow lines are usually drawn with an arrowhead at the point of entry to a symbol. The given picture shows the multi-way branching of a flowchart. The left picture specifically shows you the three-way branch, and the right picture shows you the multi-way branch. Let's look at an example of a flowchart. Here you have to draw a flowchart to add marks of 10 subjects obtained by a student at an examination and to print the total marks and the average marks obtained by the student. Let's look at the macro level solution of the given question. First, you can start drawing the flowchart by using the terminal symbol while writing start on it. After the starting symbol, you can draw a parallelogram since you have to do the input to the program, and under that, according to the question, you can write read marks of 10 subjects. After inputting, you have to do the process, and for that you can draw a rectangle, and on that you can write down add marks giving total. According to the question, in the next stage, another process is happening, and for that also you have to draw a rectangle, and there you have to find the percentage of the given marks while dividing the total by 10. After finding the percentage, you have to output total and percentage, and for that you can draw a parallelogram to represent it. And finally, you can draw the terminal symbol to end the flowchart according to the question, and you can write end on it. And now let's look at the micro level solution of the same question. Let's discuss about read marks of 10 subjects micro level solution. First, you can input the marks as I, and you can equals that to 1. Then you can read the ith mark to mark 1. And next, you have to make a decision to find whether the given I is equals to 10 or not. And to represent that, you can draw the decision symbol. And if it's equals to 10, oh, that means yes, then you can go to the next step called as add marks giving total. And if it's not equals to 10, then I should be equals to I plus 1, and you have to repeat the same process until the value gets equals to 10. Let's look at the add marks giving total micro level solution now. The input of this process should be the output generated from read marks of 10 subjects. Here you have to imagine that the I equals to 1 and total is equals to 0. Then the total will be equals to total plus mark 1. Here also you have to make a decision to check whether the I is equals to 10. If I is equals to 10, that means yes, then you can go to the next step of finding the percentage by dividing the total by 10. And if it's not equals to 10, that means no, then I should be equals to I plus 1, and you have to repeat the same process until the value should becomes equals to 10. And in this picture you can see the both micro level solutions together. Now you can clearly understand the previous macro level solution was generated from the micro level solutions which we have discussed above. It's time for us to move to the second representation of an algorithm. That is pseudocodes. Let's look at an example of a pseudocode to obtain the sum of two numbers. This is how you should write down the pseudocode for the above question. Number 1. Begin. Number 2. Enter the first number and the second number. Number 3. Total should be equals to number 1 plus number 2. Number 4. Display the sum, and number 5 should be the end. Next part of today's lesson is the evolution of computer languages. The evolution of computer languages include first generation computer languages called machine languages, second generation computer language called assembly languages, third generation computer languages called high-level languages, and fifth generation computer languages called artificial languages. Let's look at the differences between high-level and low-level programming languages. High-level languages take less time to write, typically shorter than an equivalent low-level program, and easier to read. And also, high-level languages are portable. That means it can run on different kinds of computers with few or no modifications, and low-level programs can run on only one kind of computer and have to be rewritten to run on another. Let's learn few points regarding the low-level programming languages now. Every computer is based on a set of instructions built into the hardware. That means the machine code. These instructions are simple and specific to the hardware of the particular type of the computer. Those are designed for the hardware but not for humans to follow, and also it is directly executable by a computer's central processing unit. A machine language can be considered as a hardware-dependent programming language. Let's look at the differences between a program and a programming language. A program is a sequence of instructions for the computer to carry out a specific task or tasks. Programming language is an artificial language designed to communicate instructions to a computer, and also a notation for writing programs and a notation for specifying computations or algorithms. In the next part, you are going to learn about the programming language translators. The first programming language translator is the interpreter. Interpreter is a computer program that directly executes instructions written in a programming or scripting language without requiring them previously to have been compiled into a machine language program. A compiler is a computer program that translates computer code written in one programming language into another language. Let's look at compilers and interpreters together. In this picture, you can see how the compiler and interpreter works together as a hybrid. Let's meet again with the second part of the lesson. Subscribe to get notified about the second part.